Okay, this is me working out the problems for assignment 8.3 with the law of cosines. For the record, this is my third time to get started because one of the common errors that you might run into is getting your A's and your B's and your C's in the right location. And I've had to restart this once or twice because I've been making messes. Blame it on the snow. So let's go ahead. I'm going to use fresh paper and we're going to solve this first triangle. Triangle number 1 looks like this. We have an angle of 40 degrees here. We have a side of 6 and a side of 2, and we don't know what this one is. We'll call it little b, and then we'll call this angle A and angle C. And we need to find B. We want to find B equals A equals approximately C approximate. That's what we're looking for in your problem. So the first thing we're going to do is we're going to find that third side. And for the law of cosines, I'm going to use c squared equals a squared plus b squared minus 2ab cosine c. Now I just want to show you, in case this helps you, you've got all three sides represented here, this with the squared values. The one that you have on the left matches the angle opposite on the right hand side of the equation. And then you have this coefficient of AB, which are the two terms here. So the two values that you're using in the first two terms, A and B. So there's a little bit of balance to this, in case that makes sense to you. If not, just use the formula. Okay, so let's go ahead and let's use B squared though now. B squared equals A squared plus C squared minus, and then this is going to be the two here, A and C, and the angle is going to be opposite the B. So we don't know what B squared is, but we do know what A squared is. That's let's just put little a equals 2, C equals 6, and angle B, capital B, equals 40. So those are the three values that we know, and we're finding the other three values. So B squared equals A squared, which is 2 squared, so that's 4. C squared is 6 squared, which is 36, minus 2 times A, which is 2, times C, which is 6, cosine B. Oh, so now we know what B is, that's 40. So we can do all of this. There we go. Now we have everything in there that we need. We just need to solve for it. And since everything is on the right hand side, we will just use our calculator here, and we will just keep a running value. So 4 plus 36 minus parentheses here 2 times 6 cosine, so that's times the cosine of 40. Close parentheses. So 4 plus 36 minus 2ac cosine of 40. That all equals 21.61, and that's the square of b. So let's see, b is going to be the square root of that. So what we'll do is, using your calculator without touching the memory, we'll go to the square root sign here, so control square root, and then we'll get the answer. We'll pull it from memory by going control answer, goes right in there, and then enter. So b equals 2 decimal places, 65. So that's the first thing we needed. All right, next we want to get the angle A. So we're going to use this expression, but remember our balance. So if we're going to look for the angle A, that'll be in the cosine. Then we're going to use A squared equals B squared plus C squared minus 2BC cosine A. So once you know what you're looking for in the angle, it has to be in this cosine at the last term and then balanced with that side on the left-hand side of the formula. So let's see. So A squared is 4 equals B squared, which is 21.61 because we did that out of the calculator, and C squared would be 36 minus 2 times B is 4.65, C is 6 cosine A. So we're going to bring these two terms over and then divide by this one. I'm going to show you this one once, and then I'm going to do more shorthand as we go forward. 4 minus 21.61 minus 36 equals negative 2, 4.65 times 6 times cosine A. So I want to show you that this one time, and then after that we'll let the calculator handle it. We're going to divide both sides by this. So we have 4 minus 21.6 minus 36 divided by negative 2 times 4.65 times 6 equals cosine A. Alright, so let's just do that in the calculator. So we have, and I like to use the parentheses so I don't make any mistakes, 4 minus 21.61 minus 36, close parentheses, so that's our numerator, divided by, parentheses again, negative 2 times 4.65 times 6, close parentheses, and this is going to give us the cosine of A, 0.96. Now without taking that out of the calculator, I'm going to, this is the cosine, but I want A, so cosine inverse of 0.96 is going to equal A. And that's what we're going to do. We're going to hit the cosine inverse, so trig, cosine inverse, oops, go backwards, bounce my fingers, cosine inverse of the answer, so control answer, and I get my degrees, so A equals 16.1 degrees. So we have 4.65 for B, we have 16.1 degrees for A, and we need C. Now, do we have to go through this again? No, we already know two angles. So what we need to do is C is going to equal 180 minus 40 minus what we just found, 16.1. So that's going to equal 180 minus 40 minus 16.1. It's 123.9. There we have for number one. Number two has a similar triangle. Oh, this side we have all three sides known and none of the angles known. That's not going to be a right angle. I'm redrawing them over here since I've already written all over the page. So A, B, C are my angles. So little b is 4, little a is 9, and little c is 6. So I have all of the sides and none of the angles. So the first thing we're going to do is to find A. I'm going to find A. So I'm going to balance my equation using the a squared on the left. So a squared equals b squared plus c squared minus 2a, oops, see that I did it, minus 2bc cosine A. And I want to pause here to make sure I fill in the right blanks. So I've got these two terms, B and C, and I've got B, C there, and I've got A over here, and I've A over there. So I'm good. So let's plug it all in. So A is 9, so 9 squared equals B is 4 squared plus C is going to be 6 squared minus 2 times B is 4 times C is 6 cosine A. So like we did up there above, we're just going to solve. So I've got 81 minus 16 minus 36, that's these three terms, divided by negative 2 times 4 times 6. All of that equals cosine A. Let's do that in the calculator. I'm going to use the parentheses this time. 81 minus 16 minus 36, close parentheses, divide, parentheses again, negative 2 times 4 times 6, close parentheses. Again, this is cosine A, and it is between negative 1 and 1, so that's good. So what I'm going to do next is I'm going to leave it in my calculator, go to cosine inverse of that answer, and that equals the degrees, 127.16. We round up to 2. So I have A. Now I need to do B. So let's do B squared equals A squared plus C squared minus 2AC cosine B. Let's make sure. Little b over here, big B in the angle, AC, AC. Okay, this time I'm not going to get it right. So B squared is 4, so 16 equals A squared, which is 981, plus C squared, which is 36, minus 2 times 9 times 6 cosine B. Make sure I got that. A is 9, C is 6. All right, so let's do what we did before. 16 minus 81 minus 36 in the numerator. Divide that by negative 2 times 9 times 6. That's all going to equal cosine of B. All right, so let's go with, use my parentheses again, 16 minus 81 minus 36, close parentheses, divided by parentheses, negative 2 times 9 times 6, close parentheses. All right, I did get an answer between 0 and, or negative 1 and 1, if you can see that. So we're going to do the same thing we've done, and we're going to hold that in memory, go to our trig functions and cosine inverse. Then we're going to bring up that answer, control hyphen there, and this will give us our angle. So B equals 20.7 degrees. Okay, so now all we need to do is get C, and C equals, I should say a little bit of equals. We're going to start with 180 minus A, 127.2, minus B, 20.7. So we don't have to go through the law of cosines again, we just have to do the subtraction. So 180 minus 127.2 minus 20.7 gives us 32.1. So here we have C, A, and B. A and B we use the law of cosines, but C we just had to subtract from 180. Okay, let's move on to number 3. I'm going to try to do it in the space provided. So let's see if we run out of space. So here we don't have little a, but we do have B equals 9 and C equals 3. And we have angle A equals 40. We don't have B and we don't have C. All right, so first of all, let's find A, and we can use the A squared equals B squared plus C squared minus 2BC cosine A. And we have all of those values on the right, so that should be easy to plug in. B squared is 9, so 81. C is 3, so 3 squared is 9, minus 2 times 9 times 3 cosine of 40. Okay, so we can do all that in the calculator. So we'll start with 81 minus 9. Oops, sorry, already that was plus 9. 81 plus 9 minus parentheses 2 times 9 times 3 times, so we have all those values, times the cosine of 40. Close parentheses. And so that's everything. That is going to give us the square. So 48.6 is the square of A. So now we need the square root of that. So we will simply go control for the square root, and then we will control for the answer, and then enter, and we get A equals 6.97. All right, so we have all three sides. Next we need to find B. So let's use the law of cosines again. So angle B, so that means we start with b squared on this side. A squared plus c squared minus 2ac cosine B. And this time we'll have to use what we did before, where we have everything except for cosine B on the left-hand side. So let's start with b squared is 81. Subtract a squared from that. That would be 20 point, let's see, where's a squared was 48.63. You'll get that from the calculator for a squared. And then minus c squared, 9. That's all minuses because we brought them from the right hand to the left hand side. And then we have negative 2 times a, which is 6.97, times c, which is 3. All of that equals cosine B. All right, so 81, I'm going to do that again. I like to use the parentheses. 81 minus 48.63 minus 9, close parentheses, divided by, open parentheses, negative 2 times 6.97 times 3, close parentheses, all equals negative 0.5588. I'm going to not worry about that because I'm keeping it in the calculator. And now I'm going to get the B using the inverse function. So trig cosine inverse of that answer. So I'm going to pull the answer in, and I'm going to hit enter, and I get an angle of 123.9. All right, so we've got A and we've got B, so what do we do next? We only have to, let's see, 6.97 for me. B was 123.9. C, all we're going to do is subtract everything from 180. So let's go with, I'm just going to do this one since we have it. So we have 180 minus 40 minus 123.9. So those are our three values. And so we're left with 16.1 for our last angle. All right, let's look at number 4. One more time. We're getting good at this, I hope. That's the whole point. So we have A, I like to write this, A equals 5, B equals 6, C we don't know, A we don't know, B we don't know, but we know C equals 70. Okay, so let's find C squared, or let's find C first. C squared equals A squared plus B squared minus 2AB cosine C. Looks good. So we don't know what C squared is, so we're just going to plug in what we know. So A squared is 5 squared, so 25, plus B squared is 36, because B is 6, minus 2 times 5 times 6, cosine of 70. All right, let's put all that in the calculator. Ready to go. 25 plus 36 minus parentheses 2 times 5 times 6 times cosine of 70. You see that? And we get C squared equals 40.478. So that means we want to take the square root of that. So control square root. Control pull in the answer. And then the final C equals 6.36. 6.36. Okay, so then angle A. So we're going to set up our law of cosine. So angle A, so we're going to start with A squared on this side equals B squared plus C squared minus 2BC cosine A. I've got everything in the right spots. So A squared is 25. I'm going to go ahead and do what I've been doing. So I'm going to bring these over as I write them. 25 minus b squared, which is 36, minus c squared, which we can tell from here was 40.48, all over negative 2 times b, 6.36 times c. Oops, that was c, so b was 6. That should work to be cosine A. Alright, so let's try that. Using my parentheses to keep it clean, 25 minus 36 minus 40.48, close parentheses, divided by, parentheses again, negative 2 times 6.36 times 6, close parentheses. And I get, that didn't work again. My parentheses are not working for me right now, so let me try that one last time. So parentheses, 25 minus 36 minus 40.48, close parentheses, divided by, parentheses, negative 2 times 6.36 times 6. I see what happened there. I had to hit the plus instead of the times there, so you've got to be careful how you enter things. And so now I have cosine of A, which is between negative 1 and 1, so 0.67. However, I'm going to leave it in there. Let it focus. Okay, so we're going to do the inverse cosine, so trig, cosine inverse, got that. Now we're going to bring in the answer, and then we will see A is going to equal 47.58, so we'll round to 6, for 47.6 degrees. And we already have one other angle, so for B, we just need to do 180 minus 47.6 minus 70 equals B. 180 minus 47.6 minus 70 equals 62.4. There we go. So again, we've repeated ourselves pretty much for all 4 problems. Let's move on to more of a little bit more challenging. Alright, so in this one it says either use the law of sines or cosines. So let's just do what I like to do here, making my little table of what I have. A equals, we don't have, B equals 6, C we don't know, A we don't know, B is 28, and C is 87. So first thing I'm going to do is the easy stuff. I'm going to find A by subtracting B and C from 180. So let's go 180 minus 28 minus 87. Those are the B and C angles that are given, and so A is going to be 65 degrees. Now, I like to use the law of sines because there's fewer terms. So why don't I do that? And I'm going to solve for A first. So I'm going to do the sine of A over A equals the sine of B over B. Alright, so sine of A is 65, so sine of 65 over A equals sine of B, which is 28, sine of 28 over 6. I like to use the values that were not approximated, whenever I can. So let's cross multiply and divide. A equals 6 times the sine of 65 divided by the sine of 28. So that was by isolating the A, and this is how it works to be manipulated that way. So let's just do it in the calculator. So 6 times sine 65, tab over, divided by sine of 28 equals 11.58. So A equals 11.58. Okay. So now let's do the same thing for C. So sine, what is the C angle? 87 over C equals the sine, we'll do the B again, 28 over 6. So C equals 6 times 87, 6 sine of 87 over the sine of 28. And let's do that again. So 6 times sine 87, tab, divided by sine of 28 equals 12.76. And with those angles, there's only one possible solution. So A is 65, little a is 11.58, and C is 12.76. All right, let's move on to number 6. All right, here we have A is unknown, B is 3, C is 14, and A is 65. So let's find this angle B. To find angle B, sure. So let's use the law of sines here. Sine, oh wait, we don't have that. Let's wait one more second here. First we have to find A, so let's find A first. We need another side. Alright, so A squared equals B squared plus C squared minus 2BC cosine A. And we know all of those, so let's see, B squared was 3 squared. I'm going to write it out this time because I don't know 14 squared off the top of my head. 2 times 3 times 14 times cosine of 65. Okay, so A squared was 9 plus, what's 14 squared? 196 minus 2 times 3 times 14 cosine 65. Let me just do that. All right, let's do this in the calculator. So 9 plus 196 minus parentheses 2 times 3 times 14 times cosine 65. And so A squared is 169.5. So we need A, not A squared. And the interesting thing, this looks really close to the perfect square 13. So let's try this, control square root, control the answer, and that enter is equal 13. So A equals 13.01, and to run digit it is 13.0. So now we have 3 sides, 1 angle, and let's try to set up a law of sines. So let's go with sine of A over A equals sine of B over B. So sine of A is sine of 65. B, let's see, A is 13. Sine of B, we don't know. And little b is 3. So sine of B equals 3 sine 65 divided by 13. So 3 times sine 65 tab 13. Okay, so then this is the sine of B, which is 0.209. But we're just really writing that down. We want to get this into the calculator, so we'll go the inverse sine of that answer. So it's trig sine inverse of the answer, so control answer. And we get an angle B equals 12.07 or 12.1. So we have two angles and one side, so we're still going with one triangle. A is 13.0, B is 12.1, and C is going to be 180 minus both of those. So 180 minus 65 minus 12.1. And we're left with 102.9. Okay. Now we're going to do the application problems. And I think for this, I'm going to pull back on the paper. So we have enough room. I'm also going to do one little thing. I want to make sure. There we go. So going forward, I hope we'll have a better view of the calculator. All right, so we have a cruise ship on number 7. And it's going from Barbados south to San Juan. So this is Barbados, and this is San Juan. And we have a storm. So this distance is 600, but it's headed this direction at an angle of 20 degrees. And his speed is 22 knots. What else do I need to know? And he gets to some point here, and he has to make a course correction to get to Barbados. And that's the angle we're looking for eventually, and this distance. So let's see, 22 knots. So let's look at what he's done. So the cruise ship maintains 22 knots, sailing, and the distance is a total of 600 miles. To avoid the storm, he heads out to San Juan at a direction of 20 degrees off course. He maintains 22 knot speed for 15 hours, at which time he's over here, and he needs to head this way. And so we need to figure out what this angle is, which is going to be the supplement to the angle we're going to calculate. And let's see what else we need to know. So he's been going for 15 hours. So the first thing we want to know is how far along has he gone? So this is the same thing as 22 times 15, or 22 knots times 15. He's gone 330 nautical miles. So we have two sides and an angle. So let's start with finding out what this, let's see, what do we need to know? We can use either one. So we have two sides and one angle. I think we can use the law of sines here. So let's try that. Keep that there. So let's say we're looking for this angle. We call it B. Call this one A. Before we can do that, we need to find this third side. So let's go ahead and find this third side using the law of cosines. So let's call this angle B. So that would be little b. So little b equals 600. B, we don't know. C, we'll find out. So let's see. This one would be up. Let me change that around. I've already labeled that Barbados, so I'll make this one little b, and that one became 330 because that's how long they were traveling at 22 knots. So let's say A, B equals 330. And C, it's going to be 600, let's call that. So that means capital C is what we don't know. 330 we also don't know. What's opposite that is B. And A is 20. So we have the problem set up. We know two sides and one angle. And we need to find this length first, and then we can solve for this angle here. So let's go with A squared equals B squared plus C squared minus 2AC times cosine of A. Put all that together, 330 squared plus 600 squared minus 2 times 330 times 600 cosine 20. Now we can do all that on the calculator, and I've made it bigger now. So let's go with 330 squared plus 600 squared minus, use my parentheses for safekeeping, 2 times 330 times 600 times cosine 20. Close parentheses, and I get A squared equals 96781.7. I'm going to get the square root of that by just control square root, control answer. So A is 311 miles. All right, so we have our A. All right, so then we want to get, I'm going to use the law of sines to find this angle, which will be the supplement for the angle that we need to set him straight. So let's go with sine 20 over 311, which is the opposite of side. Then we have sine of C, because that's the one that's opposite the 600. Wait a minute. Just making sure my numbers are right, so go ahead and check yours as well. Okay, let's see what happens. I've done this before and I've had a little bit of trouble. I'm looking for sine of C, so 600 sine 20 over 311 equals a sine C. 600 times sine 20 tab divided by 311 equals 0.65. I write that down, but really what I need to do is use that in the inverse sine. So we'll go to sine inverse of that answer. and I get C equals 41.3. That is the answer that we need to adjust. Now we need to find the distance. So the question is, how long will it take him to go to Barbados? We have the length was 311, and so we'll take 311 divided by 15 knots per hour. Let's try that again. 311 divided by 15, and I get, what did I just do wrong there? Oh, of course I did. I did 15 hours instead of the 22. So 311 divided by 22. So if something doesn't feel right, usually isn't. 14.1. So really 14.1 hours to get to Barbados. All right, last three problems. All right, so we've got what looks like a lake, but it's actually a kneecap. And here we have a PreCal triangle located at the end of the femur. It usually identifies the gender of the skeletal remains. So here we've got a nice forensic problem. So AB is 31.8 millimeters for me. AC is 51.3, and angle A is 85.6. And we want to find BC. All right, so let's just let's call this C squared, or let's call that C, and we can solve the others. So let's say C squared equals A squared, so let's call that 31.8 squared, plus B squared, 51.3 squared. I'm running out of room here. Bear with me, so I'm going to continue on the next line. Minus 2 times 31.8 times 51.3 times cosine 85.6. You missed all that. Sorry about that. So this is the, I'm going to try that one more time. C squared equals 31.8 squared plus 51.3 squared minus 2 times 31.8 times 51.3 cosine 85.6. A little bit better. All right, so we're just gonna, this is real life, so real life is always messier than the practice problems. So let's just take it one step at a time, make sure we get our decimals in the right place. 31.8 squared plus 51.3 squared minus parentheses 2 times 31.8 times 51.3 times cosine of our angle, which in my case was 85.6. Close parentheses, and that all comes to 3392. I'm going to take that and square root it, so control square root, control answer, control enter, and I get C equals 58.2. And what does this say? So the length is approximately 58.2 millimeters, and the gender would normally be identified with, let's see, if it's around 59.4, it's close to males, and if it's around 53.3, it's female, so this is a male femur. Alrighty, so 2 more problems. Let's see where we're at. Number 9, we have a baseball field, and the one thing that and this is hard to see in the cover, so let's see. So I've got my diamond, which actually is a square, and that's a key point. Each side is 90 degrees, and this is second base and third base, and they're going to go way out here, straight from center field down to home plate, and that's going to be 401. All right, so what we want to do is find the angle, find the distance from center field to third base to throw this guy out. So what we have is we have a side, 2 sides, and no angle, but the assumption we're all going to make is that everybody understands baseball and that this is 90 degrees, so this is 45 degrees. Yeah, I had to look that one up myself. So now we have a triangle that looks like this. We have a 90, a 401, and a 45 degrees. So side angle side, and we're looking for this, so let's use the law of sine. So c squared, we'll call that c squared, equals a squared plus b squared minus 2ac cosine of 45. So let's fill that in. So that's 90 squared plus 401 squared minus 2 times 90 times 401 times cosine 45. Alright, so again we'll be able to do all of that on the calculator, so let's see how we do. So 90 squared plus 401 squared minus parentheses 2 times 90 times 401 times cosine of 45. And I get a very large number, so I'm not going to worry about that. I'm going to go to the square root of that answer, and I'm going to get 343.3, which makes a whole lot of more sense. 343.3, what is this, feet? Yes, feet from the center field fence to third base. And if you want it in two places, so let's make it 3-1. All right, last one. Now we can choose to do either the law of sines or the law of cosines. What do we know? Let's see, we have A we don't know. Oh yes, we do, 20. B we don't know. C we don't know, but we have A we don't know. B angle is 11 degrees and C is 73. So I have, first thing I can do is the easy thing. Let's find out what A is. And A is just the difference from 180, subtracting those two. So 180 minus 11 minus 73. So A is 96 degrees. So we did the easy one. Having done that, I can use the law of sines, which is slightly easier. So sine of A over little a equals sine B over little b. All right, so let's go the sine of 20. Nope, sorry, sine of 96 over 20 equals the sine of b, so sine of 11 over little b. All right, so b is going to equal 20 times sine of 11 over sine of 96. Let's do that in our calculator. 20 times sine 11 tab divided by sine 96 equals 3.837, so round it to 3.84. So now we can do the same thing with C, so sine A over A equals sine, what is C? 73 over C, so we have sine 96 over 20 equals sine 73 over C. So C is going to equal 20 times sine 73 divided by sine 96. 20 times sine 73 tab divided by sine 96. Control enter, and C is going to be 19.23. And we have one triangle And so that's going to be A is going to be 96, B is 3.84, and C is 19.23. And the way we know it's only one triangle, because if there was a second A2, let's just put an if, A2, then A2 would be 180 minus 96, which would be well, actually, I'll take that back. There is no second one because, really simply, we've already been given B and C. So there's no difference there. So we have only one angle, one triangle, and we have those answers. All right, hopefully this helps you. Thank you.